So, hello, my name is Jakob. I'm from Copenhagen, where I've been working on the project of, for this presentation, I actually have a short presentation later as well, but for this presentation we have been spending the past 2.5 years traveling around the world and visiting projects within 3D printing in construction. We have visited places in Asia, in Europe, in the US, in Russia, all over the world to see what is the state of the art, what are people doing, which technologies are they using, why are they doing it, and so on and so forth. So the end of this project was finished this January actually, where in February we launched a report in Danish, unfortunately, but hopefully soon it'll be in English as well, where we are covering the basis of what is actually going on in terms of real projects out there in the world. So yeah, I'll try to go through this today and try to give a global overview of what is happening within this field right now. And as I said, later today I'll cover the project we did ourselves in Copenhagen, but I won't go into detail about that right now. So who are we? We are actually a 3D printing company. We have no background in construction whatsoever, but 3D printing is our specialty, and we saw this area moving forward, and we decided to spend some time digging into it. After that, we have actually spent more and more time and more resources in this field, and now we are actually just about to put all our balls in one basket, so to say, and work entirely in this area in the future. Because we find it very exciting, and I'll give you some of the reasons here. Also, there are a lot of reasons to go into the construction industry with automation and 3D printing and other technologies. And some of the main advantages, just before we go further, is obviously the design freedom. We've heard a lot about this yesterday and today, that this complexity is for free statement. It's not totally true, but it will be, I guess, in the future. Automation aspects as well, lower cost, higher productivity. If you look into the construction sector, you'll see the whole industry hasn't actually increased that much in productivity if you compare to regular manufacturing and so on during the past 40 years, and there are many reasons for that. It's not weird at all, but this is one of the technologies we believe can maybe add to the solution for that issue. Less mistakes, better safety, higher precision. Definitely not yet, but in the long term. Faster completion time, reduction of waste, new materials, etc. There are many great advantages if we look a little bit ahead in this area. So the global scoreboard right now. This is from December 2017, and this is buildings. So if you look to Europe, we have 2 completed buildings at that time. And by buildings, I mean real finished structures that actually have a permission to be used as buildings. So not test objects. The other ones are in structures or other projects. If you go to Asia, we have a lot more, and I guess actually this number is a bit low, but those are the ones we could verify are actually being built. So it's always very hard to tell if you haven't been there yourself, if it's actually been 3D printed or if it's actually been something else. But these are the ones we could verify. The US at that point won. One more came here in March this year. And so a total of 14 buildings 3D printed in the world. Very few, but it's still 14. If we look at other structures, we have a couple of bridges in Europe. 4 other structures like bridges and so on in Asia. Nothing in the US as far as I know, so 6 in total. And if we look at the projects worldwide, we are roughly at 66 projects. It's actually higher now because I think we made the total count back in September last year, and a lot has come to actually added to the field now. But it's a very fast moving field, and a lot of people are going into this area, so it's very hard to take like a snapshot of this and present it. If we take a short look at the projects here, this one is our own project in Copenhagen, one of the 2 in Europe. As I said, I won't go into detail with that right now, it comes a bit later. The other one is a project in France, in Nantes, where there's actually here you can see we've used an extrusion of concrete, and in France they actually printed the insulation foam and cast the concrete afterwards. So you can say it's the reverse way of working, but very, very interesting project as well. If we go to Asia, this one I think someone presented yesterday. It is, I think, 3-4 years back. The Chinese company Winsun, they announced they had built like 10 buildings in 24 hours, and it cost like nothing, and so on, so forth. And since then, they have actually been printing a lot of other structures, some quite impressive ones. They're definitely the leader in the terms of number of actual projects realized. But as you can see here, this is the real printed surface. So this is the printed part. This has obviously been there's been a lot built to it, and I will come more close to that fact later. We have something in Dubai that's also printed by the Chinese in China actually, and shipped to Dubai. We have some more houses in China, a couple in Russia, and some things in Dubai. Those two, this one is on the building side. This is an actual hotel suite. It was big in the media a couple years back as well in the Philippines. This one in Yaroslavl in Russia is also a real project. This one is in Moscow or close to Moscow. It's on a construction site as well. So it means these of these 5 projects, these 2 are not, you can say they don't have a building permit. They don't really live up to any standards. They're just produced on a construction site. But these 2 are in use for real, and this one as well. If you go to US, a bit behind in terms of number of projects, but ahead in some other fields. But the US military announced this building last year, and then this year in March, I haven't included it in the total count, but I wanted to show it as well. It's a house from a company called Icon. That launched this house as a concept for cheap homes in the future in the US. So this is actually all the finished constructions in the world. So it's very, very easy to get a global overview. Thank you so much. Now, obviously, I want to say a couple of words to that. A short conclusion on the overview. As I said before, it's very, very difficult to make a complete overview of an industry that is developing so fast, because new projects just pop up like every single week. New things happen. And obviously some projects are going under the radar and are not big in the media. So if you're not very attentive or by accident stumble upon them, it's not sure we have them with in the project. So you can say that's a quick snapshot of what is actually being published out there. So there might be some projects we have missed as well, obviously. But yeah, 66 projects worldwide. And by projects, it could be, for instance, universities researching in a field for more than just one project, but for a longer time, like this project here or so. So if you could say something in general about what is happening where. So if we look at Europe, we're actually leading in terms of number of projects and the level of research here in Europe, because you can say we don't have that many buildings compared to Asia, for instance, but we have many more projects and a higher level of technology, I would say, if you look at the European research institutions and also the European companies. I think we will catch up in the terms of number of projects very soon, because it is starting to be easier to get the permits, and once it's been done once or twice, it's getting easier. So I think we will catch up soon. Asia is definitely leading in terms of commercialization of this technology. But also, if you look at the base of what they are doing, the advancement of their technology is they're using the very simple form and shape of the technology, but they are really doing a lot with it. So you can say in that area we have a lot happening, but the research is really developing in Europe. The US, for a number of reasons, is actually quite behind, and as you see later, it's a bit weird because it was invented in the US by a guy called Kuznets, who has claimed, I think, around 100 US patents within this technology. So that might have scared competitors off. It could also be something with the the ways you insure houses in the US that keeps them back. But now we have 2 houses, so it's the same in Europe. So it could be that they are actually developing fast as well. Yeah, and then again the Middle East, but yeah, right now we count that as Asia, will be actually moving a lot forward, especially Dubai and Saudi Arabia is really pushing into this area. And most European and Chinese companies who are working within this field are actually working as well in Dubai and Saudi Arabia to do new projects. So just to give you an idea of which types of technologies are being used out there. So this is one of the most used technologies. This is the Gantry printer. So we have basically we have movement in 3 directions on a very stable, very simple construction. As you can see, it's the way the University in Eindhoven are printing, and it's the way we have printed, and so on. We have the pros of a very stable, very simple construction. Obviously, it's quite difficult to move because you need to like uninstall all this base here, and you need to move it and set it up and calibrate it and so forth. So it's very stable, easy to use, but it's difficult to move. So we have also seen quite a few of these machines in construction halls, like this one in Eindhoven, and fewer of them actually on site, except for our own here. Then we have the robot arm, the robotic arm. So usually this is there's a couple of European companies that work with this. This one, it's Cybe, for instance, and X3. So you take the concept is you take a standard industrial robot, which are quite easy to purchase, and then you apply a printing extrusion nozzle of some kind, as you can see here and here, and then you make shapes. And obviously it's a smaller mechanical system. It's very well supported by the industry. It's standard robots, so you can get spare parts everywhere. It's easy to move. It's more expensive. It's a bit more difficult to program and to control. And you have a more limited printing area compared to the other ones. So there are advantages and disadvantages. And as you can see, just an example of our house, if you take our robot here and took conventional industrial robot, here you won't be able, I think this is one of the biggest robots you can actually achieve, or you can actually get. It's really hard to print an entire structure. So for the robot arms, it will mean that, and you can see that around right now, definitely that the robot's arms are printing more in terms of modules that you actually apply to the buildings. And the gantries are printing either entire buildings or they're printing like larger modules. So that's the difference right now between those 2 technologies. There's a couple of more. For instance, the powder-based print we heard about just before. And some crane systems, but they are not very widely applied yet in the construction industry. Then there are, in terms of construction, you can build on-site or you can build in a construction hall. And obviously when you print on-site, you have the advantage of no assembly, so you can just print directly and you can have a house. The disadvantage is that you really need to move the printer out there and set it up and calibrate it and get everything to work. You are quite vulnerable to the weather conditions, to environment, to temperature changes and moisture levels and so on. Which if you go to the in-hall production system, then you will have very high control of your environment. You'll have the same stable environment every day. So it's very easy to print a lot and have stable conditions. But on the other hand, you'll have to transport the elements out to the site and install them there. So you have, obviously there are applications for both, and both are being used out there. Yeah, as you see, all the Chinese ones are made in a factory and then transported and installed on site. In terms of history, if we go a little bit back, as mentioned before, Kosnevich Birok, I think he coined the term in '95, but formed the company Contour Crafting a little bit later. He was the first who actually started to taking this additive manufacturing into the construction industry. Since then, during the zeros, it was kind of slowly picking up. We saw Loughborough University going into the field. Dini who I believe made the technology for the powder-based printing technology in Italy, is actually quite early as well. Loughborough works on. They're now, I believe, working with Skanska. But then, if we go, it might be a bit tough to see from there. This is 2012, and this is 2015. So you can see a lot of projects coming into the field. There's not been any slides like this made since, but it's really, really exploding right now. So these can also just be small test or research project, but there's so many people going into the field right now. So it's really, really amazing. It's really interesting field to be in because so many different things is happening all the time. But if we look at the state of the art, where are we in terms of this technology, and can it actually be used out there in the construction industry? If we look at how technologies usually are adapted into a culture, we usually see an introduction of technology where we have mostly innovators, so people like all of you and people who are really thinking ahead of themselves, who are the audience. Very small market, very high prices, low sales, low competition, and the actually overall focus of the business is awareness. It's actually going out to tell about the technology, to showcase, to do tests, and obviously learning and development. And then when you get, if you get further, you'll hit maturity and actually have a market. But just to be very, very clear, the overall technology we're here. If you look all the way around, all houses being built right now with 3D printing are demo projects. We don't see any demand. It's very, very slowly beginning, but the demand is close to zero. It's maybe, I don't know, 0.01% of the construction industry who are interested in this technology at this point. But obviously they will change. But right now we need to recognize we are really, we are here. It's a new technology. So, but that's all right. It needs time to develop. If some of you guys have heard about this curve, the Gartner's hype cycle, it also describes if you take a new technology and put it into the market, then at some point in the early years you'll hit this is the hype going upwards and the time going outwards. You'll see crazy articles and you'll create this media hype. You've seen it like with many other technologies like VR, like cell phones, like computers, like internet, and so on. You'll see it in almost every new technology you get introduced. You'll have some type of hype that at some point will disappoint because people think it can do a lot of things and then it can't really do anything. And then the whole media, the common people, they lose the interest, but then the industry move forward and they create maybe the second generation of the machine, and then they move a little bit forward and create the third generation and actually start making projects and so on and so forth. And then slowly it will come in. So our estimation based on what we have seen right now is that we are actually just about this tip right now. So we have seen a lot, if we go over here, we have seen a lot of crazy claims in this industry. I don't know if you are obviously from the industry, so you might have seen some of the YouTube videos, but for instance, we have this office of the future in Dubai. Wow, so much design, so interesting, and so on. But then you go to China and you see the real thing behind all this shell. And it's obviously it's still impressive. It's 3D printing, but it's really a simple shape. You could have cast that quite easily. And all the interesting details, the interesting architectural details are actually made by craftsmen afterwards. So there's like this one. It's really, really interesting, and a lot of media attention, like a lot of articles, but this is the real deal. This is what 3D printed. And then we go out to see, like, 3D printed a house in 24 hours. And they said that in 2017, in February. But we went to visit them in the fall of 2016, where they spent 3 days printing this. So this is obviously not true either. So there's a lot of this hype being created out there that's simply not true. And obviously, if we go back, so here, you can see the focus is awareness. So it's not weird, it's all right. But I think maybe if we are not want to disappoint the industry too much, maybe it's a time to cut down a little bit on the hype and start making bit more real projects. Last thing, I don't know if anyone actually got to notice this. There was a company called Casa who wanted to build skyscrapers in 2022 with an app. They're closed now, but it was just another example of it's just not doable. You need to be realistic here. It's really good to dream and have visions and look 10 years into the future, but you also need to say, what can we actually do? What is possible right now? And also, we've seen a lot of hype around the pricing. For instance, you'll see YouTube videos where they say, we printed a house for $1,000. All right, cool. I want to buy a house for $1,000. Someone called you the day after. But then you go into the economics of it. And if you look at the pure production cost of a house, then you have, this is really raw. Obviously, there will be variations. But let's say a high estimate is 25 or 35% of the price of the house is the row house, which means slopes, carrying walls, roof, floor, deck, etc. 35%. Right now, everyone who is printing, 3D printing anything in construction, they're only biting into this area. And there are still few of them are doing roofs, but most are not doing roofs. So let's be honest. We are maybe going into 20-25% of the price of the house. So obviously, the claims, there was a claim by McKinsey, I think a half a year back, who said that the 3D printing could save like 80-90% of the cost of the house, but that's very, very difficult if you're only working within the 35%. So obviously, there are some things for the future when we start to bite into these areas, to finish, to paint, to install doors, to all these other areas. But right now, to be completely honest, we are here. Everyone is here. And if they say they're not, they are simply lying. It's not true. But it's also, it's all right. It's completely natural for new technology. You don't have to be world champion the first time you do something. It's completely normal to, like for instance, most of the houses you've seen right now, except for the Chinese ones, are one of a kind. It's companies who've only made one house in total in their complete lifetime. So obviously they need some experience in order, first of all, to be cheaper, to be better, to be competitive, and so on. And with that experience, I think it's possible that we can print a house in one day and it can be really, really cheap and so on, but we're just not there yet. But the good thing, if you look at the positive side, it maybe look like I'm really, really negative and pessimistic about the industry, but I'm really optimistic actually. I'm just a realist. But if you look at the past years, you have seen actually quite a lot of the conventional construction industry going into this field. So we've seen investments from Perry, the German scaffolding company, Vinci, one of the world's largest construction companies. We've seen investments from Sublime, Sika, material guys here, construction guys, Bouygues, Skanska, the Swedish company, are really looking into it as well. Caterpillar. And Doka and many more of the large established companies in the world are actually looking into this field. Some of them because they see a threat actually to their own business in the long term, and all other of them because they can see it as an advantage to their product in the future. So, but I think that's a really, really good sign, because at some point this needs to happen when you have such a very and a very slow-moving industry. We can't really do anything without these guys. We can do some innovation, but in the end, we need the large players in the field to move along. If we are not only talking about one demo house and one demo project, but if we actually want to do some grand scale and do a lot of construction. Last slide. Innovation. It happens really, really fast. As you've seen in cell phones, I don't know, you probably heard a lot of people say it, but this one, all of you have it in your pocket right now. Nobody had it like 10 years ago. It's really, as soon as it catches, it's going really, really fast. So it's all right if it's bulky and weird and doesn't really work and really expensive in the beginning, because it's just technological, digital development. It takes time, but before you know it, we're there. So thank you very much.